Welcome, grade 11 Mindsetters. We are on Learn Extra Live for a great grade 11 show with Natasha. How are you, Natasha?
I'm good. It's nice to see you.
Nice to see you too. It's been a while, hey?
It has. You guys, you go through stages.
Yes,
we see a
we
lot
do
of you
weekly.
or none of you.
No, yes, that's exactly it. I've missed you guys so much because I wasn't here last week. So now I know that, you guys missed me too because I've been hearing stuff on the page. So that is fantastic. What are we doing today?
Grade 11s, get ready for 2D trigonometry. Remember,
Okay.
in 2D, we look at all your sine, cos, area rules. So that's what we're going to be looking at.
Awesome, that's fantastic. You can prepare your board.
Thank you,
So you guys know exactly how to get a hold of us. Obviously, Learn Extra at Learn Extra for Twitter. And our Facebook page is facebook.com/Learn Extra. You guys know we love the interaction. We love your questions. We love your comments. We just love you. So just make sure that today you are on the ball on our Facebook page because it's Monday. Thank you to Liberty for an awesome show. And we also have some prizes. We have our Casio calculator that you can win, as well as our Casio labeler. So just make sure today that you are the most fantastic mindsetter on the page, just so that you can stand a chance to win one of our awesome prizes. Since it was the weekend, let me know how your weekend was. I look forward to hearing about your guys' weekends because I told you I missed you. So I need to hear about that. So make sure today you are on the page totally. Over to you, Natasha.
Thank you so much, Katleho. And guys, welcome to 2D trigonometry, grade 11s, and some of you grade 12s that have tuned in. It is important. It is a section of work that you need for grade 12. I mean, you need all of the work that we do, but this is one of the important ones. So just a reminder of what two-dimensional trigonometry is about. This is all about finding angles and distances between points, okay? And in grade 10, you learned using the 90-degree triangle, how you can solve the triangle. That means how you can find the sides and how you can find the angles. But in grade 11, you are introduced to the sine, cos, and area rules, and that helps you to work in triangles and to solve those triangles where there's no 90-degree. All right, so that's what we're looking at, sine, cos, and area rules. So the first thing we're going to just go over briefly is the sine rule. And the sine rule can be used when either you have more than one angle in a triangle and a side, or if you have two sides and an angle. Very important though, when you have two sides and an angle, the angle must not be included. Okay, if the angle is included, then you can't use the sine rule. You've got to perhaps go for the cos rule, or work around it, and you may need to actually sort of do a longer approach to the question. Okay, if we come across those, I'll point it out then. But generally, if you've got two sides and an included angle, then you're looking at the cos rule. All right. So talking about the cos rule, it can be used when you either are given three sides, and then in that case, remember guys, if you're given the three sides, you're actually then going to be finding the angle. Or if you've got two sides and an included angle. And I'm going to put the formulae up for you. I just want to go through all of the different things first. And then the area of any triangle can be found if you know at least two sides and an included angle. So important that the angle is included. And why is it important to know when something's included or if it's not an included angle? You'll see a lot of the times it actually helps you to decide what rules you can and cannot use, because there's so many things you can do when you have to solve triangles. You're looking at sine cos rule, you're looking at if it's a 90-degree triangle, then all of your SOHCAHTOA rules, and you can also use Pythagoras. So there's so much that you can use. It's important to know what you're given and when you can use each. All right, so a reminder, the sine rule, it's A over sine of angle A is equal to B. Remember, these little B's and little A's are actually the names of the sides of the triangle. And I'll quickly draw a triangle to just remind you about that. So if I have some triangle A, B, C, then remember that the side opposite angle B is called little b. the side opposite angle A is called little a, and then the side opposite angle C is little c. All right, so we've got the sine rule. Let's just write down what the cos rule says. All right, so again, for any triangle ABC, if I'm looking for side A, then A squared is equal to the sum of the two other sides squared minus 2 times BC cos of the included angle, so cos of angle A. So for example, let's go to this diagram. If I was looking for side A, in other words side BC, then I would need to know what the length of B is, what the length of C is, and I'd have to be given that angle A. All right. And then obviously you can manipulate the formula. So you can manipulate the cos formula to look for the angle. Okay, so if you've got all three sides, you can rewrite the formula and then you can work out what the angle is. The area rule, okay, remember that's for any triangle where you've got two sides and an included angle, then your area is equal to a half of, so if I've got, for example, say I've got side B and side C, it would be a half BC sine of angle A. All right. Now we're going to look at a diagram that will help us to decide when we need to use what formulae. But let's just remind ourselves of all the things we can use. Yes, we can use sine, cos, and area rule. And then remember, for your SOHCAHTOA, sine is opposite over hypotenuse, cos is adjacent over hypotenuse, and tan is opposite over adjacent. You can only use those in 90-degree triangles. And then you also know your Pythagoras, x squared plus y squared is equal to r squared. So you've got so many different formulae to choose from, and it can become really overwhelming. So you need to know which rule to use when. So this first question is designed, or this first example is designed to help you understand which rule you need to use when, and we're just going to go through each of these questions, which are true or false questions, and we're going to look at which statements are true or false and how we can determine the ratios by looking at the given information, okay, and we determine which rules we need to use. All right. So guys, they give you triangle, the big triangle, NOM, okay? But if you look at this, there's actually two other triangles within NOM. There's triangle NO, and we can call this, let's call it Z. Okay, so there's triangle NOZ, and then there's triangle NZM. Okay, so in total, you've got 3 different triangles, so many different ways they could ask you to solve this triangle. They've also given you that NZ is perpendicular to OM. Okay, we've got that little red sign there, which means it's at 90 degrees. Therefore, obviously, the adjacent angle, using angles in a straight line, would also be a 90-degree triangle. All right, so as soon as you see a 90-degree triangle, you need to remember your SOHCAHTOA. Okay, remember that at the back of your head. If we have a 90-degree triangle, we can use any of these rules depending on what sides we've been given. All right, so we've analyzed it. We've got 3 triangles, and you see that they've labeled the sides OM. All right, if we looked at the side OM, they've called the whole side B, and then that's divided into 2 little portions of Y and X. Okay, and the reason for that being because we're actually working in 3 different triangles. So in the big triangle NOM, we're going to refer to OM as side B, and then in the little triangle NOZ, we've called it Y, and in triangle NZM, we've called it X. Okay, so we've differentiated that one side into 3 different little pieces. All right, we've called side NO little a, and then side NM has a little c, and then NZ is H. All right, so we won't say NZ anymore, we'll say H. Okay, let's have a look at the first question. Remember, we're trying to show whether this is true or false. Okay, so they said cos of m, and they've given us a ratio. Now, before you even look at the ratio, cos of m, let's have a look where that is. Okay, there we go. That's angle m there. That cos of that angle can fall in triangle NZM. And if they had told us that triangle NOM was right angled, we could also use angle M in that triangle. In this case, we don't know that triangle NOM is right angled, so therefore that restricts us to triangle NZM. So the ratio that they want you to find, cos of M, okay, so you see there's so many different triangles that we can use, but we've already ruled out the big one. It doesn't have a 90 degree, and we're looking at the SOHCAHTOA rule with the way this has been set out. So we know that that restricts us to triangle, this triangle NZM. All right, so cos of angle M, remember your rules, cos is adjacent over hypotenuse. So if I were to label, this would be, this little x part would be my adjacent to angle M. And then the hypotenuse, remember, is always the same. It's always the one opposite the 90 degree. So therefore, C would be the hypotenuse. And then the angle, the side that's opposite angle M would obviously be H. All right, remember, we're labeling things according to the angle that we're looking at, and the angle here is M. So cos of angle M is going to be adjacent over hypotenuse. So it's going to be x over c. So the first one is true. All right. So guys, if you're following at home and you've quickly made a sketch of this diagram, I hope that you got the first one right. All right. So cos of m is equal to x over c. That is true. Okay, let's have a look at the next one. They say that a squared is equal to b squared plus c squared. All right. And I'm just going to erase what we've got on just so we can see nicely what's going on here. Okay, so they say a squared is equal to b squared plus c squared. So we're looking at this one, that one, and that one. All right, as soon as we see these squares in this kind of format, we know we're probably looking at the cos rule. So they say a squared is equal to b squared plus c squared minus 2bc sine of m. And hopefully that rings alarm bells immediately, because yes, if I was using the cos rule, I'll start by saying a squared is equal to b squared plus c squared minus 2bc. All of this is correct so far until we get to this point. Remember, it's called the cos rule for a reason. We have to make use of the cos ratio. And here we don't have cos, we have sine. Okay, so this one is false. All right, so this formula should be minus 2bc, and instead of sine m, it should be cos m. Okay, all right, so carrying on, we're going to move on to one with the sine rule now. Guys, just remember that we're looking, each time we're looking at how the information that we've got, and we're deciding which triangles that restricts us to and where we should be working. Okay, so let's look at number 3. Let's see which triangles we should be working in. We've got side C. Okay, so that could be in the big triangle or in the little one here. We've got side A, which is in the big triangle or the other little triangle to the side. And we've got angle O and angle M. All right, so immediately we can't be working within the two little ones because all of our information is directing us outwards, out to the bigger one, out to the big triangle. So therefore it looks like the sine rule. So if I were to state the sine rule without looking at what they wanted, I would say it's A over the side opposite, the angle opposite that side, which is sine M, is equal to, and if we're using C, it's got to be the angle opposite C, which is angle O. So it's going to be A over sine M is equal to C over sine of O. And is that what they have? A over sine M is C over sine O. Yes, they do. So this one is true. All right, so hopefully all of you are following me and you're finding this diagram quite useful. It is a really nice way to show you how you can use all these different sets of rules that you have. So don't forget the old stuff just because you've learned sine, cos, area rule. You still need to know all of the old stuff. All right, the next one says h squared. And once again, I'm just going to erase because it can get confusing with all these other marks and angles and that. Okay, so it says that h squared is equal to a, so h squared is equal to a squared plus y squared. Now, the squared formulas you know. Think about them. Which ones are they? They are either the cos rule or Pythagoras. Okay, those are the two squared formulas that you know. The cos rule would involve, obviously, a cos. This doesn't have a cos in it. Okay, so this is going to be the Pythagoras formula. Okay, remember Pythagoras in a 90-degree triangle. You've got to remember Pythagoras. The sum of the hypotenuse squared is equal to the sum of the two shorter sides squared. So therefore, in triangle NOZ, because angle Z here is 90 degrees, then A is the hypotenuse, because remember the hypotenuse is always the one opposite the 90 degrees. So then we'll have A squared is equal to the sum of the shorter side squared. So it's going to be equal to H squared plus Y squared. Okay, so that's from your Pythagoras rule. A squared is equal to H squared plus Y squared. What do they have for Pythagoras? They've got H squared, which is one of the shorter sides, is equal to the sum of the other two. And we know that that's not true because by Pythagoras, we know that the hypotenuse has to be the longest side in the triangle. So this one is false. Okay, and then finally, we've got an extension of the cos rule. So this looks like the formula has been rearranged. All right, and we're looking for cos of angle N. So let's have a look at the diagram. Let's see how we would sort this one out. So angle N is that angle there. All right, so if I wanted to work out, or if I wanted a cos N in my equation, I would have to start by looking for side B. Okay, so say that you were looking for side B, then your equation would include an N. So just think about it for a second. B squared would be equal to A squared plus C squared minus 2AC cos of angle N. All right, so that means if I want to find angle N from the cos formula in the way that they've written it, okay, remember we're just going for this because of the way they've written it, I need to actually write out the formula then for finding side B. Okay, all right, so I'm going to write out the cos formula because remember, you can learn how to work out each of the angles off by heart. It's really not advisable though because it can get really confusing and you can make silly sign mistakes in that. So we're going to start from scratch. We're going to say the formula that would include angle N would be if I was trying to find B squared from the cos formula. So I would say B squared is equal to A squared plus C squared minus 2AC, and then it would be cos of the included angle, which in this case was N. Okay, so there we have the N in this formula. All right, and all we've got to do, because you can see all your variables are in this answer, we've just got to figure out whether what they've written there is true or false. So what we're going to do is rearrange the formula B squared is equal to A squared plus C squared minus 2AC cos N. We're going to rearrange it and try and get cos N as our subject. All right, so first thing we're going to do is move this term to the left, and we're going to move the B squared to the right. So we'll get 2AC. Okay guys, all I'm doing is rearranging the subject of the formula. So it's 2AC cos of angle N is equal to a squared plus c squared minus b squared. All right, if I'm looking for cos of angle n, I divide 2ac, divide it out on both the left and the right hand sides. So I'll get cos of angle n is a squared plus c squared minus b squared all over 2ac. All right, and now if you have a look at what they've given you, they've said a squared plus b squared minus c squared. They've swapped around these terms. Okay, it should be a squared plus b squared and then minus the c, so it should be a squared plus c squared minus the b squared. So they've swapped the signs and those two terms around. Okay, so therefore this formula is false. Okay, and it was quite a long process to get there. We didn't just remember formulae and remembered, you know, it's got to be 2 times this side. And I know there's strange ways that some of you sometimes come up with to remember finding the angles and that kind of thing from the cos rule, but we didn't do that. We worked from the basic cos formula and we worked out the subject of the formula. So this first example was just designed to show you how you can use all of your different rules in one triangle where there's different triangles that make up that triangle. And I think that's a good point to take a break.
Yes, it is. That was fantastic. I know you learners really did enjoy that question and were thoroughly involved. So that's fantastic to see. Take a quick break because you deserve it. We'll see you right after this.